Calc, we're going to start in lesson 5 today. We're going to look at sum and difference formulas, and we're going to be looking at these 4 formulas in this first part of your notes. In a little bit, I'm going to compare this set of identities to what we have on our identity reference sheet, and I'll show you what that looks like here in just a little bit. Okay, as we get going, I'll explain why these formulas are important, and if you're interested in the derivation of these formulas, I have that all worked out. It uses the distance formula. It is something that I don't know if it's in your textbook or not, but it's certainly part of the college trig curriculum. But if you were in my classroom, I would show you where these formulas are coming from. But since you're not, I'm just going to let you have the formulas and we'll play around with them and I'll show you how to use them. All right, if I ask you to find the cosine of 75 degrees, some of you have calculators that would just give you the answer. Some of you have calculators that would give you a decimal answer. Some of your calculators have answers that are going to be exact. Some calculators, like I said, will just give you the exact answer, and it's radical 6 minus radical 2 over 4. Now, you're going to be going, okay, you can also just get that as a decimal, right? So cosine 75 degrees is also 0.2588. So if you type cosine of 75 degrees into your calculator, you're going to get one or the other representation. If I said you had to find the exact value, this is the answer you want. But some of your calculators don't give you that answer. So I'm expecting all of you to be able to use these formulas to get this answer right here. So we are interested in where this answer comes from. For these problems, you cannot just go from the problem to the answer. You have to show the work. So these formulas are going to give you the work that show you how to get this exact answer. Now, another thing to point out is that 75 degrees is not one of our unit circle angles. Remember, those are multiples of 30 or 15 or 30 or 45 degrees. 75 degrees is not one of those angles. So if I just relied on my unit circle, I'm not going to find 75 degrees on there. But what I can do is I can break up 75 degrees into 2 angles that add or subtract to 75 degrees. So the work's going to look like this. One pair of angles that make 75 degrees that are on the unit circle are 30 degrees and 45 degrees. Now there are other pairs that add or subtract to 75 degrees. This is the easiest pair to come up with. Could I use something like, let's see. We did 30 and 45. Could we do, say, 135 minus 60? Is that still 75 degrees? It sure is. So you can use different pairs of angles just so that they add or subtract to be 75 degrees. So I'll just put that on the side. Cosine of 135 degrees minus 60 degrees also works. So just a side note. All right, from here, I'm going to go back to my formulas. And I'm going to use this one right here. Why? Because I have A plus B, and I have cosine. So the formula says I take cosine of A, so that's 30 degrees, times the cosine of B, and then I subtract the sine of A times the sine of B. And then I go to my unit circle and I find the cosine of 30. The cosine of 30 is radical 3 over 2. The cosine of 45 is radical 2 over 2. The sine of 30 is 1/2. The sine of 45 is that. And then I have radical 6 over 4 minus radical 2 over 4. And I think you can see now where this answer from your calculator is coming from. Okay, so if I decided instead I wanted to try cosine, and I saw 75 degrees as 135 minus 60, the answer is going to be the same, but the work's going to look a little bit different. So if I go this route instead, it says cosine of A, so cosine of 135, I'm just following the formula, times the cosine of B. Now, B is not negative 60, B is 60. And then, and I don't even need parentheses there. I'm not sure why I drew those, but. And then it says plus sine of 135, sine of 60. So if I go to my unit circle, the cosine of 135 is going to be negative radical 2 over 2. Cosine of 60 is 1/2. Sine of 135 is radical 2 over 2, and the sine of 60 is radical 3 over 2. If I clean that up, I get the same answer. So again, it doesn't matter what pair you use for your angles as long as they add or subtract to be that 75 degrees. So you can see that they're the same. Okay. So on this one, it's the sine of 15 degrees. So you have to think in your mind, okay, 15 degrees, it's not on the unit circle. My calculator might just give it to me in decimal. It doesn't matter. You're going to have to show the work. So the sine of 15 degrees, how can I add or subtract two angles to get 15 degrees? That's the question you're asking yourself. And so you sit and think for a little bit. Look for two angles on your unit circle that are 15 degrees apart. You have lots to pick from. You could do 45 and 30. You could do 60 and 45. You could do 120 and 135 and so on. So any two angles 15 degrees apart. The first two that I see on my unit circle are 45 and 30. Then I'm going to follow this formula right here. So that's the sine of A, and then the cosine of B. And again, B is not negative 30, it's just 30, minus the cosine of A and the sine of 30. So remember, this is your A, this is your B, and you're just plugging the values in. Radical 2 over 2, radical 3 over 2, minus radical 2 over 2, and 1/2. So these values are coming straight off your unit circle. And there's my exact answer. Okay, find the exact value of cosine of pi over 12. Well, you have some options here. You can play around with fractions. Or it might be easier just to switch those to degrees first. If you play around with your fractions, how can I get 1/12? Well, one way to get 1/12 is to take maybe 2/12 minus a 12th, but we know a 12th pi is not on our unit circles. So maybe if we did 3 pi, 3 minus 2, is that a way to get a 12th? Well, that's pi over 4 minus pi over 6. These again are on my unit circle. Okay, so I'm doing cosine and subtracting. So I'm going to use this formula that I'm highlighting here in pink. Okay, so again, A is here, B is here. Plug them into the formula, catch the sign. Find these on your unit circle. Oops, I have a mistake here. That should be a time sign. And we have the square root of 6 plus the square root of 2 all over 4. Okay, I'm going to pause my video here so I don't go over 15 minutes, and then I just had one more problem to show you today.